Anyone?
Can we do set number 79?
79. Very good. In 79, we have f of x, which is natural log. What is the base of natural log? I don't see the base. What is exactly? Please always remember, natural log is the inverse function of e to the x, so the bases have to be the same. Good. So now it's natural log of a quantity. What do we know about this quantity? What type of quantity should it be? Exactly what we just did. So what will you write about x minus 2 everything squared? Because this is the quantity that natural log is applied to. What should I write? This should be what?
X minus 2 squared is greater than 0.
Awesome. But you can say this is always positive. Yeah, but it could be 0. If you just look at this, you'll say, yeah, this is always positive. It's always strictly greater than 0. Yeah, but it cannot be 0. So x minus 2 cannot be 0, which means x cannot equal 2. So what is the domain then of this function? Everything works except 2. Why 2 doesn't work? We just looked at it and it screamed at me, right? 2 minus 2 is 0. Natural log of 0, it will scream at me again. So how do I write the domain then for such a function?
Negative infinity to 2 union 2 to infinity.
Brilliant. Thank you so much. I appreciate it. Thank you. Great. So I think we got the domain. We are aware of the fact that this is, every time I see a log of any type, an alarm comes on. And I always remember, like these two functions, I have to state a restriction. And what is the restriction? Whatever log is applied to has to be a positive number. Good. That's good. Thank you for answering. I really appreciate it. So now, my next step is very, very, very important. Okay. Any exponential equation can be replaced by a log equation. Comma, and vice versa. That is the most important. Any exponential equation can be replaced by a log equation. Any log can be replaced by an exponential. And you can say, what are you saying with this? In a minute, right now. What does this mean? Log base b of x that we just looked at equals a number. Double equivalency. What does this mean? This implies this. This implies this. Any log equation can be changed into an exponential. Any exponential into a log. And here is how. We always start with the base and we go counterclockwise. B, not times y. Careful. B raised to power y equals x. B raised to power y equals x. Any exponential can be changed into a log equation, any log equation into an exponential. Okay. So now here is something that we should have started with, but I had to wait till this moment. Here's the definition of log. What is the log? This is log. What is this? What is it? Is the power we raise the base to get this number. So what is a log? A power. We raise the base to get x, which is also the very, very important statement that I just made. Any exponential can be changed into a log. Any log can be changed into an exponential. So now let's practice this a little bit. See how we change from one into the other. I am sharing my screen. Where are you guys? Okay. Now let's take a look. So here they are. Write each equation in equivalent to logarithmic form. Write each equation in the equivalent exponential form. So we want to look from 1 through 20. So let's choose one from here, one from here. You choose or I will. That's a warning. I'm kidding.
$13.
13 it is. And from the first set, so we chose 13. Perfect. And let's choose also one from 1 through 8. So I can stop sharing and we work on these problems. Okay,
Can you please
which one?
number 6?
Number 6. Perfect. So in number 6, we have 3 equals log base b of 27. And then I'm going to copy also, you said 13. Where is 13? Rosie, I see it. The cube root of 8 equals 2. Perfect. Okay, so let's start with 6 and then 13. Now, all I have to do is just mimic this. It really is nothing difficult, right? So I'm going to rewrite it as I see it here. Log base b of 27 equals 3. I'm going to write a double equivalency. And I'm just going to copy b raised to the 3rd power equals 27. Not b times 3, please. B to the 3rd equals 27. Nobody's asking me to solve this equation, but do you have an idea what b could be? We're not asked to do this. So we are only asked to, from the log equation, replace the log equation into an exponential equation. Always from the base. We always start with the base. Raised to the power equals x. So can anyone give us an idea of what could be b?
3.
Yes. There is only one number because they are one-to-one functions, right? They will not have inverses if they weren't. So 3 to the 3rd is 27. Again, this is an extra question. This was not asked. Okay, now let's look at this. For 13, I am given the cube root of 8 equals 2. So I have to come up with the log equation. But you could say, this doesn't really look like an exponential. Well, it does and it is. So don't look at this side. Let's just change this into an exponential expression. You can say, but this is the cube root. Yes, but any root can be replaced by an exponential expression. Okay? So can anyone tell us how to write the cube root of 8 as a base to a power? I'm ready.
So
2
third.
cubed.
Yeah, cube.
8 to the,
No, it's 2. Oh, I already. 1/3.
very good. Yes,
Yeah.
power 1/3. Remember, any radical is a fractional exponent. It's an exponent that is a fraction. So now, this is this side. I have a base, I have a power, and I have a number. So now let's write the other side. The other side has to have log, has to have a base, has to have a number, and has to have a power. So can anyone tell us what is the base? What base do I have to write in here?
8.
Of course, because it's the same base here. Good. What power do I have to write in here?
1/3.
Excellent, because that's the power here. And what number do I have to get? Of course, that's the only one that is left. So 8 to power 1/3 equals 2. 8 power 1/3 equals 2. Great job. Any questions? Any questions here? Okay, so let's quickly browse through. We can read from graphs. We know who we looked at a transformation. We look at domain. These properties will be discussed right now in 4.3. Okay, so we're going to get to those. The next section, which page am I on? 6. Okay. 4.3. Properties of log functions. Properties of log functions. These properties are very important, and you will not find other functions that have these properties. Okay? So here's number 1. Product rule or property. If we apply log in any base, base B, any base, of a product, A times B, this is the same thing with the sum of these two logs, log of A, log of B. Log of A, oh, you know what, I'm used to writing base A, and log of B. These are dynamic. I can have this to write this. I can have this to write this. So here's a simple example. Log of 2x. With parentheses or without parentheses, mean the same thing. This is the same with log of 2 plus log x. But if I'm given, for example, log 3 plus log y, how will I change this back into what?
Log 3y.
Excellent. Log 3y. So this is a very important property. When we expand something like this into some or more, 2 or more logs, we are expanding. When we go back, we are condensing. We are condensing from 2 logs into 1. Okay. Quotient rule. Exact same thing. Log base, any base of A over B. What do you think? What is a wild guess here? It's okay if you're wrong. If you're not wrong, I will not have anything to say. So, what do you think?
Log A minus log B.
Exactly. Log A. A minus log B. Exactly. So if we expand, let's say log of 3 over x, how would you expand this?
Log 3 minus log x.
Excellent. And now we can also condense, right? So like the previous property, Goes back and forth. I can expand or I can condense into one log. So let's look at an example right here, right now. So let's say log x minus log y minus log z. I'm stretching it a little bit just to make sure that we understand something very important. How many logs we see here? Just kidding. How many?
3.
Good. How many of them have negative sign in front of them?
2.
2. Because they have a negative sign in front of them, these two quantities will come from the denominator. So when I want to condense this, I have x over y, z. Only because they have negative in front. Yes, you can factor out -1 and use the property twice, yada, yada. That's fine. Nothing wrong with that. But it's so much easier to remember. If a log has a negative sign in front of it, its quantity has to come, if you condense it, if we go back, right? Its quantity has to come back from the denominator. This one has positive in front. Its quantity has to come from the numerator. So now when I want to expand real quick, something like log xy over x squared plus y, this is in the numerator, this is in the numerator, but this which cannot be broken up is in the denominator. Let me just spice it up a little bit and put a z in here. How will you quickly expand this? And how many logs will have negative and how many logs will have positive sign in front of it?